All right, this lesson is going to go through some more things that will happen when you're dividing radicals. We kind of got through the basics in the last video where we talked about what happens when they divide evenly, what happens if they don't divide evenly. We looked at the process called rationalizing. So we're going to extend that now to what if there's multiple terms in either the numerator or denominator and we're still trying to do division. So for example, if I look at this first one, you'll notice there's two terms in the numerator, still a single in the bottom. Well, you're going to have options to do these questions. In this one here, what you might want to do before you start is always reduce your radicals. What that will do is make the multiplication steps that you're going to use here shortly a little bit easier. It's not a big deal in this question, but in some of the ones you'll see in a moment, it'll really make things a lot easier if you reduce first. So let's just reduce this radical. So I'm going to pen here. I'm going to so it's the square root of 18 is 9 times 2. Square root of 9 is 3. Multiply that by the 8. This is 24 radical 2. None of the other radicals reduce, so that's going to make things a bit easier. All right. Well, it's really the same as what we were doing before. Before, if we had just monomials, if I had 2 over the square root of 3, they don't go evenly. That's not a radical. That is a radical. They don't even divide. But what we learned is we rationalize the denominator. We multiply the numerator and denominator by whatever square root is in the denominator. That's the process you use if the denominator is a monomial, single termed. Now sometimes you can say, oh no, that's not a monomial. Yeah, even though there's a coefficient, it's still all considered one term. So it is a monomial. Nothing changes. We're going to multiply the numerator and denominator, in this case, by the square root of 5. Now, it's whatever radical is present in the denominator. Notice you do not need to put the coefficient here, the 3. You can. It just makes for more work, though, if you do. So you just pick the radical part, multiply numerator and denominator. All right, so if I scroll down, the difference being now, this radical 5, there's no brackets around the numerator of a fraction, but they are always implied brackets. It's implied that this, even though there's no physical brackets drawn on there, that's understood to be in brackets, which means this radical 5 has to multiply by this one and this one. Remember, you can only multiply the radical part by the radical part. This one has a 1 in front of it. That's why it makes it easier. So if this is a 1 rather than a 3, all I got to do is go 1 times 24. Blue here. So this will equal 24 square root of 10. That's radical 5 times this whole thing. Now I'm going to multiply radical 5 by this one. And that will be plus 10 square root 30 in the denominator. 3 times 1. That's 3. The square root of 5 multiplied by the square root of 5. That just gives you a 5. Denominator is rationalized. No more radicals left in the bottom. Have a quick look at the radicals that you created through your multiplication to make sure they don't reduce. In this example, they do not. So I have 24 square root 10 plus 10 square root 30. Everything will be over 15. The one last thing you have to check for in terms of reducing is, obviously I've said the radicals already, but then the final step is you check the coefficients, 24, 10, and 15, and you ask yourself, is there any number that divides evenly into all of the coefficients? It has to divide into all of them. If it does, then it will reduce further. 24, 10, and 15. There is no number that divides into all 3 of them. So I am in reduced form, and I am finished that one. All right, let's go to the next one. So the next one progresses a little bit in that it's got variables in there. But I'm not going to do it any different. I'm going to reduce anywhere I can first. So this radical is not in the simplest form. So I'm going to leave the ones in the numerator. 2x square root 3, subtract 5x, 4x, 8. I'll show this one. 8 is 4 times 2, x to the 7th. So 7 doesn't divide. Because it's a square root, I have to be able to take half of the exponent, which I cannot. So I'm going to rewrite x to the 7th as x to the 6th multiplied by x to the 1. Now I can take the square root of this one. Numerator stays the way it is. Oh. So it's 2x, square root of 3, subtract 5x, denominator. All right, so I've got 4x, the square root of 4. I'll just write it out. Again, I might do more of this in my head as we get going, but just to get you back into things so you see what's going on here. The square root of 4 is 2. That's not a perfect square. X to the 6th is a perfect square. Its square root is x to the 3rd. So the ones that were not perfect squares will stay underneath that radical, like so. Now, if we just keep on tidying these things up, I've got 2x radical 3, subtract 5x, divide that by, multiply these two together. That'll give me 8. Add the exponents when you multiply. That'll be x to the 4, radical 2x. Now, like many things that you're finding in mathematics as you progress through your pre-calculus courses, they can be labor intensive. That means they take a fair bit of work. And this is one of those types of questions. It's going to take you a little bit of work to get through to your final answer. We're only at the point now where I've got everything all simplified, but my problem now is, you remember we said we're not allowed to leave radicals in the denominators of expressions anymore. So I have to figure out a way to get rid of that. Well, we know how to do it. It's called rationalizing. So I am going to, just like I did over here, multiply by the radical that's in the bottom. The radical in the bottom is square root 2x. I'm going to multiply the numerator and denominator by the square root of 2x. Now remember why you're allowed to do that, because this expression, anything divided by itself, is really nothing more than a big number 1, which multiplying something by the number 1 will not change the value of it. We're just trying to change the appearance of it because we don't want a radical left in the bottom. Okay, like the last one, you have the implied brackets here, which means this must multiply by both of these. 2x, there's no coefficient, so it'll just be, it will be 2x. The square root of 3 times the square root of 2x will be the square root of 6x. Minus 5x times 1, minus 5x. There's no radical part to multiply here, so it'll just be radical 2x. Now the denominator, I have 8x to the 4th. Square root of 2x multiplied by the square root of 2x. Remember, the square root of anything multiplied by the square root of that exact same thing just gives you the radicand, the number underneath the radical. All right, getting there, almost. All right, so all I have left to do, these don't simplify, the two radicals. They're not like radicals, I can't collect them together, but this can multiply. So I got one last thing to do here where I multiply these. 2x, square root of 6x, nothing happens. 2x, and the only thing that'll happen now is our denominator will become 16x to the 5th. 8 times 2, 16. Add your exponents, remember that's a 1. Check your coefficients, 2x, 5x, 16x to the 4th. Is there anything, number or variable, so last time we only had to talk about numbers, now we're going to worry about variables. Is there any number? Let's start with those first, 2, 5, and 16. Nothing divides into all three of them except 1, so those don't reduce. However, x, x, and x to the 5th, all of those terms divide by x. So I'm going to divide each of these by x, and that will result in this as a reduced answer, 2 square root 6x minus 5 square root 2x, and the denominator will be 16x to the exponent 4. All right, so those two examples go through how you manage when the the numerator has multiple terms in it, and the denominator is still a monomial. All right, next scenario then we're going to examine is, what are we going to do if there's multiple terms in the denominator? A student say, well, why do we got to do something different? I'll show you why you got to do something different. If we just try and apply the same strategy, watch what will happen. You say, well, there's a square root in the bottom, it's square root 2. Just multiply the top and bottom by that radical. Okay, let's try. Radical 2 equals square root 12. Now, remember, there's implied brackets here. Square root 2 times 5. 5 radical 2. Square root 2 times square root 2 minus 2. Now, do you remember the goal of what we just did here? The goal of this, it's called rationalizing the denominator, with an end result of hoping to end up with no radicals left in the denominator. Well, unfortunately, by doing what I just did, there's still a radical left in the denominator. So this process no longer is going to help us get rid of the radical in the denominator. It just moved the problem from one side to the other. So there's the issue we run into. I need to figure out a way to get around this. Well, in order to do that, I'm going to show you a little bit of background information here first, and then we'll get into how it all works. So there's a term that you're going to have to become familiar with if you're not already, known as conjugates. Conjugates is simply, so they talk here, goes through kind of a formal definition of it, but it's really very simple. A conjugate just means something like this. If I go, before I even get to radicals, if I just said x subtract 3, its conjugate, it's when you keep the exact same terms, the only thing you switch is the sign between them. So if I had, with radicals, let's say I had negative square root 2 plus 7. The conjugate would be negative square root 2 subtract 7. The only thing that changed is the sign between the two terms, negative to plus. Notice this one. Sometimes we say, how come you left that one? Because it says that we only change the sign between the two, those two, no other signs. All right, and that's what conjugate means. So it's the same terms, but the opposite operation, addition and subtraction. Now we'll just look quickly down here to make sure we know how to write these out. So here are some expressions. Let's write out what their conjugates would look like. All right, if I had 5 subtract 2 root 3, its conjugate would be 5 plus 2 root 3. Negative 8 radical 7 subtract 2. Again, I'm just changing the sign between them, not the one in front. This would stay negative radical 12. The opposite of subtraction would be addition. Those are the conjugates of those binomials. Now this only is true for binomials. It doesn't apply if you have a monomial or a trinomial or anything beyond that. It's only applied in the situation involving binomials. Well, so that's lovely. I can see how to do that. It's obviously not very difficult. Well, watch what happens. If I take any conjugate, let's say I take the square root of 3 minus 2 square root 5, and I was to multiply that by its conjugate, well, its conjugate would be the square root of 3 plus 2 square root 5. Okay, now watch real carefully what happens here. It's a binomial multiplied by another binomial. So I have to multiply this term by this term, and then this one by this one, and then we have to multiply this one by the first, and that one by that one. So we're going to do that out, see what it looks like. The square root of 3 times the square root of 3 is going to be 3. The square root of 3 times positive 2 root 5, well, the coefficient here is a 1, so 1 times 2 is 2. The square root of 3 times the square root of 5 would be radical 15. Negative 2 times 1 is negative 2. The square root of 5 times the square root of 3 is the square root of 15. Now these two, negative 2 multiplied by positive 2, negative 4. The square root of 5 times the square root of 5 will just give me a 5, no radical anymore. Well, I've got a 3, 2 square root 15 minus 2 square root 15. Well, those two together are just going to be 0. Take away 20 equals negative 17. Now, if you kind of look that over and say, well, that's kind of neat. Do you think it was just a fluke that happened? That when I multiplied a binomial by its conjugate, look what happened. I just got a number. No radicals, nothing. Just some number left in the denominator. Well, just to show you that it wasn't a fluke, let's do another one quickly. I'll just pick an easy one here. Let's go 3 plus square root 7. Its conjugate would be 3 minus square root 7. 3 times 3, 9. 3 times negative root 7, negative 3 radical 7. Root 7 times 3, positive 3 radical 7. Positive times negative, so I know it's negative. Square root of 7 times the square root of 7 is just a 7. Again, these two give me 0. 9 take away 7, I just get a number. Well, that's interesting. If I take any radical binomial, multiply it by its conjugate, I'm getting just a numeric value, no radicals left. So that should be something that will help us to eliminate a binomial radical in the denominator of a fraction. Now let's look and just double check to make sure that, why did this happen? Well, if you look at these two binomials, this term and this term are always going to be exactly the same. So what happens if you multiply two radicals together that are exactly the same? The radical disappears. Well, that's great. When you multiply the last one by the last one, because they're going to be exactly the same, the only thing different is going to be the sign in here, same thing's going to happen. Again, you'll multiply the coefficients, that's not a big deal, that'll give you a number. But when you multiply this radical, it's always going to be the same as this radical. So those two are going to wipe each other out. That radical is going to be gone. In the middle, when you multiply, because of the signs here being opposite, when you multiply these two together, and then you multiply these two together, they're always going to be exactly the same, except one will be positive and one will be negative. They're always going to wipe each other out, these two. Wipe each other out, those two. So as we get going with these, we're not going to expand them all out like that. We're just going to quickly say, okay, now I got to recognize the fact that if I have the square root of 5 plus 2 root 3, and I multiply it by its conjugate, square root of 5 minus 2 root 3, I'll say, oh, those are conjugates. Hey, I know a shortcut. All I got to do, because I know the middle terms are going to wipe each other out, just multiply this one by this one. Always, no exceptions. That's going to be a negative. You say, how do you know that? Because these two, by definition of conjugates, are always going to be opposites. The negative might be here, well then this will be plus. Well, if you multiply a positive and a negative, guaranteed you're getting a negative. That's always subtract. 2 times 2, 4. Square root of 3 times square root of 3 is 3. 5 minus 12. Look at that, no radicals left, as we know was going to happen. All right, so using that as a tool, let's go to these situations. So I look at this one, and my issue would be, well, nothing simplifies, but there's a radical left in the denominator. We are not allowed to have radicals left in the denominator. Therefore, I need to come up with a process to get rid of it. I showed you why you can't just multiply by square root 2 over square root 2. It does not work. It just moves the problem over to here. So if it's a denominator that's a binomial, we multiply by the conjugate. Whatever you multiply the denominator by, you must multiply the numerator by the same thing. Now the reason you do that is because 5 plus radical 2 divided by 5 plus radical 2 is really just equal to 1, which you're allowed to do. There's no harm in multiplying anything by 1 because it's just going to give you the same thing. It'll look different. This radical 6 is going to multiply by both of these. So it's radical 6 times 5. Now that's a radical, that's not a radical. So you're multiply those two together, you're going to get 5 radical 6. A radical by another radical, you just multiply them and put the answer below a radical sign. So radical 12. Here we go. Conjugates. multiply these two together. We do not need to multiply the middle two because we know they're going to wipe each other out. Now I just multiply this one by this one. We said it's always negative. Square root of 2 times square root of 2 is 2. 5 radical 6 plus the square root of 12 divided by 23, which is really good. One tiny little bit of reducing we'd have left to do. So this doesn't reduce, the numbers in front don't reduce, that radical doesn't reduce, but radical 12 is not in the simplest form. So I have to reduce it. 5 radical 6 plus 2 radical 3 divided by 23. 5, 2, and 23. Nothing divides into all of those. We are in simplest form. There you have it. There's how you reduce radicals or simplify radicals with binomial denominators. Now let's have a look at this one. Now you may say, well, yeah, it's the same type, similar anyway, but it's got a radical here and here. Doesn't make one bit of difference. Still works. The same process is going to work here. Now, one thing I would suggest here is these three radicals all reduce. I would reduce the radicals in the beginning just to make the multiplication a little bit easier. So the numerator, which is 4 times 3, square root of 4 is 2 times 3, 6 root 3. 27 is 9 times 3. The square root of 9 is 3 times that 2. 6 root 3. 75 is 25 times 3. So this will be 5 radical 3. Let's multiply the numerator. Actually, I set this one up, but I didn't do a really good job. But I noticed actually these are like terms. We could group those together. 6 radical 3. 6 minus 5 is just 1 radical 3. Take the radical 3, divide by the radical 3. And in that case, because they turned out to be like radicals, we did not even have to go through the whole binomial process over here. Another way you could have done it is somebody might have recognized that, well, they all have a radical 3. Why don't you just divide everything by square root 3? That would have worked too. It's the beauty of math. You don't have to all do it the same way as long as you do things that are mathematically correct. Divide those out, they're gone. You're left with 6. Divide those out, they're gone, they're gone, they're gone. You're left with 6 minus 5 on the bottom. 6 over 1. 6. Same answer, slightly different way. You could have rationalized here too. It would have worked, would have given you the correct answer of 6 as well. But I would only get into this process if I absolutely had to. Whereas here, because of the nature of the radicals, I did not have to. Okay. Last two. This one here, I'll look it over. I do not see any simplifying. So I'm going to jump right into multiplying by the conjugate. Conjugate of the denominator would be 2 radical 3 subtract 3 radical 6. 2 radical 3 subtract 3 square root 6. Same two terms, different sign between them. Now the difference is I've got a binomial up here. Well, remember, even though there's no brackets around it, there's understood to be brackets around it. So when you go to expand this out, you're going to have to go this times this, this times this. Same thing down here. Here we go. 3 times 2 root 3. 6 radical 3. 3 multiplied by this. Negative 9 radical 6. This one times this one. Negative 8, that's your coefficients. The square root of 2 times the square root of 3. Square root of 6. Minus 4 times minus 3 plus 12. Square root of 2 times the square root of 6. Square root of 12. Conjugates, so coefficients, 2 times 2, 4. Square root of 3 multiplied by the square root of 3. That's 3. A positive times, and I'm not bothering with the middle terms because I know they're conjugates. They're going to, so that times that and that times that are going to wipe each other out. Positive times negative is negative. 3 times 3, 9. Square root 6 times square root 6 is 6. Perfect. No square roots in the bottom. Now let's clean this up. 6 radical 3. These two will group together because they're both radical 6s. Minus 17 radical 6. That'll reduce. 4 times 3, square root of 4 is 2. So that's going to make this 24 radical 3. 12. Take away 54. These two will now group. That'll give me 30 radical 3. Take away 17 square root 6. So both radicals are reduced. 12 minus 54 is a negative 42, which would be fine, full value. However, this negative in the denominator will often get pushed up here instead, and you'll see it written as this instead. Now you got to remember that there's always implied brackets, even though there's none there. So if you say, oh, I'm going to push the negative to the numerator, it doesn't just go with this one, it goes with the whole numerator. So if you do that, it would look like this. So sometimes students look in the back of the book and they don't see this, and you probably won't. They normally, in a math textbook, would not put a negative in the denominator. They would write it like this instead. So change that to 42. Push the negative to the numerator, but it goes to everything in the numerator. Negative 30 radical 3, and then that would switch to plus 17 radical 6. They might even have them in the opposite order. 17 radical 6, take away 30 radical 3 over 42. So sometimes students might have this one, see this in the back of the textbook and say, oh, I have close, but it's not quite right. When in fact, it actually is right. Because all that's happened is the negative got pushed to the numerator and they just switch the order of your terms. All good. All right, so that's a good example. And we got one more. I'll take this to a new page here just so we can have more room to work. All right. First thing I notice is that the radicals are not in simplest form. So let's get that cleared up first. So I'm going to simplify this radical and this radical. 28 is 4 times 7. The square root of 4 is 2. So it's going to become 10 square root 7. Or this isn't a radical, it's just a regular old number 4. 3 minus 72. 36 times 2. The square root of 36 is 6. Multiply that by the 2. You'll get 12 radical 2. Binomial. 2 terms in the bottom because of the subtraction separating the two. You need to multiply by the conjugate. 3 plus 12 radical 2. 3 plus 12 radical 2. Remember, this is implied to be in brackets. So when I multiply, it's going to be this times this. 30 square root 7. This times this. 120 square root 14. 4 times 3. 12. 4 times that will give me 48 square root 2. Now your denominators. 3 times 3, 9. Because they're conjugates, as I've said now in all the examples, the middle terms will wipe each other out. You do not have to multiply them out. Just multiply this one by this one. So negative times positive is always negative. 12 times 12 is 144. Square root of 2 times the square root of 2 is 2. Okay, I'm getting that. Now, no radicals that will simplify. No like radicals. So the numerator, there's really nothing else I can do to clean that up any. So I'm just going to rewrite things. 30 radical 7 plus 120 radical 14. I'm just going to put all the radicals together. And then I'll just tack the plus 12 at the end. In the denominator, we have 9 subtract 288. So that's going to be 279. That'd be negative, I guess. And like the last one, I'm not real crazy about negatives in the denominator. So we're going to take that, push it here, and it's going to go all the way through each one of these. Negative 30 radical 7, negative 120, 20 radical 2. And then I'll make that positive. Now students will say, do I have to do that? No, you don't have to do that. I'm just going to tell you that the convention used by most mathematicians is they won't put negatives in the denominator here, and they'll just jump them all up to the numerator. Having said that, if you gave me this answer, nice big check mark, full value. If you gave me this answer, nice big check mark, full value. They'd both be correct. So either or would be fine. That is the end of what I wanted to show you for examples. Your textbook has lots of great questions. Remember, if you say, well, I don't have my physical textbook home, you don't need it, because you can go to our Teams general channel, check on the Files tab, and the PDF version of our textbook is there. So you can open those questions up, answers are in the back, and use these examples down below to check up on things. All right. Good luck with your practice questions. Again, don't be afraid to reach out with examples. I think using your class notebooks for me to write notes, post videos under the teacher feedback can be very helpful. So some of you have taken advantage of that. I think some of you, if you're stuck on things, are still a little fearful to reach out for help. Please do not hesitate to ask for help if you're struggling. Thank you.